I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are going to look into 5 multiple choice questions based on modeling with geometry. We will see how rotation of 2D objects can create 3D solids, and we are going to find the volume of these 3D solids. We'll understand the concepts. Try to visualize in space how does it look like. Our approach, engaging minds, helps to connect learning, visualize solution, evolve strategies. If you want, you can join Anil Kumar classes. Send an email on the address given. Creative thinking and problem solving is key for great performance. In this video, we will see how the 2D solids can be revolved to get 3D and we'll find their volume. Let's begin with the lesson. Modeling with geometry. We are going to look into rotation of objects about a line. Here are 5 questions for you to review the concept. These are all multiple choice questions. I would like you to pause the video, answer them one by one. Question number 1 is, what is the volume of the shape formed by rotating a rectangle 360 degrees around the shorter base? The rectangle has dimensions of 10 meters by 6 meters. 4 options are given to you. Question number 2. What is the volume of the shape formed by rotating a rectangle 360 degrees around the longer base? The rectangle has dimensions of 10 meters and 6 meters. Again, 4 options are given to you. Question number 4. A segment joining coordinate points 0, 0 and 3, 4 is rotated about the x-axis. Find the volume of the cone formed by this revolution. You can select the best option. Show your work. Question number 4. What is the volume of the shape in meter cube formed by revolving isosceles triangle 360 degrees around its base with height of 4 meters and base of 6 meters? Question number 5. What is the volume of the shape in meter cube formed by revolving isosceles trapezoid rotated along its longest side with a height of 6 meters and base of lengths 4 and 7 meters? These are very important questions and they help you to connect 2D figures with 3D, which are formed by rotation. So I hope your concepts are clear. Try to visualize the solid formed, especially in most of the cases. What is the radius and what is the height? This is what you have to figure out. Formulas unknown to you, right? Let's see, how do we solve such questions? Now let's now look into the first question. Let us see, how do we solve these questions one by one? Here is question number 1. What is the volume of the shape formed by rotating a rectangle 360 degrees around the shorter base? The rectangle has dimensions of 10 meters and 6 meters. 4 choices are given to you. To solve this question, let us make a rectangle first. So we have this rectangle which has a longer side of 10 meters and the shorter side of 6 meters. Now we're saying that it is being rotated around 360 degrees around the shorter base. So what is fixed here is this shorter base. Do you see this? This is fixed. And now it is being rotated, right? So let's say it is being rotated. Then what happens really is that we get a cylinder, of course, but then the position of the cylinder is horizontal as shown here. Do you see this? Many times it becomes difficult to visualize it. Now we can write down the dimensions and get the result. So once the visual is clear to you, it is kind of simpler for us to answer. So we were given a rectangle whose dimensions were 10 meters and 6 meters. When you rotate it about a side, think that this side is fixed and then the whole thing rotates in 3D. So it is a visualization like spinning. And when it spins as shown here, it will actually form a cylinder whose height is going to be 6 meters and the radius is going to be 10 meters. You get an idea. So that is the kind of solid which you get. So it's kind of like this. Do you see when it spins like this? That is the cylinder you are looking for. Is this clear to you? So is this three-dimensional figure which you are looking at? And 2D, of course, is a cross section that gives you the radius and the height. So what we get here is a cylinder. Well, that part was clear to most of the students when I took this test. However, there was a huge confusion between how the orientation of the cylinder will be. Now I hope with this diagram it is absolutely clear. So we know that the cylinder volume is pi r square h, area of the base, which is pi r square, and the height h. And in our case, we know that the radius is going to be 10 meters and the height is going to be 6 meters. And therefore, the volume will be equals to pi times 10 square times 6 meters, and so we get this in meter cube. So which is 100 times 6, which is 600. Let me write straight, 600 pi meter cube. And therefore, option A is the correct option. Is that clear to you? So it's a good idea to work with the cross section itself and see that the side which is rotated about is kind of fixed, right? You're spinning it around it. So I hope this visual now is absolutely clear. Now I'd like you to answer the second question, which is, well, really, it's very similar. Only one difference, it is only for you to practice. What is the volume of the shape formed by rotating a rectangle 360 degrees around the longer base? The rectangle has dimensions of 10 meters by 6 meters. So if you have to rotate it along the longer base, you can again draw this rectangle. We know this is fixed, correct? So longer base is fixed. This is not going to change. And now you're going to rotate it, right? 360 degrees. So what you get really is a rectangle whose cross section you can now draw clearly from here you know this is 10 meters, and that is 6, and this is also 6. And so now we have a cylinder whose height is 10 meters, and the radius this time is 6 meters. You get the idea. And volume of a cylinder is area of the base times height, which is definitely a circle, correct? And pi r square is area of the base, and height, that becomes the formula which you can now calculate and figure out the answer, right? So the volume is pi, radius being 6 square times height of 10 meter cube. And that gives you 360, right? 360 pi meter cube. And that is option C for you. So I hope with first two examples, the concept of rotation about this, you may call this as an axis, is absolutely clear. Now let me take another example, which is a different kind in the sense that we are involving a coordinate plane. So now the question here is, a segment joining 0, 0 and 3, 4 is rotated about x-axis. Find the volume of the cone formed by this revolution. So let me sketch and then be easier for us to visualize. Idea of this exercise is to think spatially within the space, visualize and then work out the solution. So this time we have center as one point of the segment and the other point being 3, 4, right? So it says segment joining 0, 0 and 3, 4 and is rotated about the x-axis. So let's first join the segment. Let's say this is a point which is 3 and 4. Okay, so let's connect these 2 points. So here we have a point which is 3, 4. We are rotating about the x-axis. So this is the line about which we are rotating, correct? Now what do you get? Well, clearly, if I'm going to rotate about this point, I should get a cone which may look like this, correct? So you can visualize the cone. And in this particular case, the height of the cone becomes the radius of the cone. You see that? So let me complete this diagram here. And so we get a visual of what is going to be formed, right? So I'm just connecting, and the idea here is to visualize. Now we have a cone as shown here whose radius and height is clear. Since the coordinate points are 3 and 4, in that case we know that this dimension here is 3 units and the height, which is the radius, is 4 units. You get the idea. So now for the cone, we know what is the volume. Volume of the cone is 1/3 of area of the base, 1/3 of area of the base, which is pi r square, a circle, times height. Remember, in a cylinder, 3 cones will fit in. Now we know that the radius here is going to be 4 as shown here, the y value. So it will be 4 square and the height is going to be the along the x-axis 3 units will be, well, unit cube. So that becomes the solution 1 by 3. Sorry. 1 by 3 pi 4 square times 3. So that gives you the option, I think B fits in, right? 1 by 3 pi 4 square 3. But the idea here is to visualize. So I hope that is absolutely clear. Perfect. Shall we move on? So now we have another question for you, and that is, what is the volume of the shape in meter cube formed by revolving isosceles triangle 360 degrees around its base with height of 4 meters and base of 6 meters. So how are you going to solve this? So you'll say, well, around its base and height is 4 meters and the base is 6 meters. So basically, this is the triangle which you are looking for, correct? Isosceles triangle. So these sides are equal, and here you have a base which is 6 meters. And then let me say this is the height of 4 meters. Now you need to visualize it is revolving around its base. So the base is fixed. You see, this base is fixed for you. And when it revolves, what do you get? So this is a thinking question. So let me write this as a thinking question, which I'd like you to think about and then post your solutions. In case you want to learn from me, you can always send an email and we can discuss further. You can register on our website globalmathinstitute.com to learn more. Here is question number 5 for us. And this is extremely important question from examination point of view. What is the volume of the shape in meter cube formed by revolving isosceles trapezoid rotated about its longest side with height 6 meters and base of lengths 4 and 7? How are you going to solve this? Well, let's first try to sketch it at least and then think about the solution. Now, trapezoid, isosceles trapezoid, so that is the figure which is not very difficult to make, right? Okay, so we are given in this case height is 6 meters. So that is the height which is 6 meters. The base is 4 and 7. This is 4 and that is 7. It is rotated along the longest side, which is this side. It is rotated along this particular side. What do you get? Well, the hint for you is a little bit of construction here. If you look at it, it can be divided like this into three parts, where that triangle isosceles means these sides are equal. So we have the base on this side as 1.5, right? And this, of course, is 4. So that is how you could visualize the figure. And now it is, I think, absolutely clear what happens when you revolve along this axis. It is a combination of cylinder and cone, right? So I'd like you to pause the video, answer this question, and then look into my suggestions. So once again, in case you want to learn from me, you can always send an email on the given address, and you can also register on our website, globalmathinstitute.com. I hope you understand and appreciate the quality of these questions. They help you connect the concepts which you have learned earlier. Volume of 3D figures. However, in this case, geometrically, we are relating how these solids are formed using the 2D figures. In our case, we have used a rectangle, a triangle, and a trapezoid. These shapes are formed by rotation. And once you rotate, you get the 3D figures, whose volume we can always find. And now here is added exercise. So let me extend this. So in extended version, you may also find surface area also, right? So that will help you to really get the complete concept on this topic. I hope that helps. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that will be great. Thanks for your time and appreciation. All the best.